So disaccharides, okay? Double sugar. Okay, di means double, saccharides means sugar. Okay, it is a Greek word. Okay, so disaccharides, double sugar. We have 3 examples you learned in Form 3, and of course we have more examples, but these are most common disaccharides present in our food. They are the sucrose in table sugar, okay, very sweet, tasty, and lactose, also tasty, in milk. Okay, of course, in milk we can also find galactose, but lactose is much sweeter than galactose. And also maltose in barley grains. Okay, they are much soluble in water and very sweet, sweeter than single sugar. Okay, these are the examples of disaccharides commonly found in food. And how disaccharides be broken down in the body? Okay, we call it metabolites. How disaccharides metabolize in our body. And if you remember that monosaccharides is broken down in our body by respiration. It's metabolized in our body by respiration. It can be absorbed in the small intestine directly because it is small enough, and also it can enter the respiration reaction directly for monosaccharides. But disaccharide is not. Okay, disaccharides is too large to absorb directly in the small intestine. The molecular size is not small enough. Okay, and also it cannot enter respiration directly. It is not immediate fuel. Okay, we have to do something before it can be used. It can be absorbed. It can be metabolized. We have to do something, and that something is called hydrolysis. And actually, hydrolysis is equal to digestion. Okay, hydrolysis is actually digestion. We have to digest the disaccharides first, or in chemistry, in chemical term, okay, we call this digestion hydrolysis. So how can maltose be digested, or how can maltose be metabolized by hydrolysis in our body? Okay, maltose is a disaccharide. We have to break down maltose first before it can be absorbed, before it can become substrate for respiration. We have to use enzyme. Okay, chemical digestion. The enzyme, we call it maltase. Okay, ASE, ended with ASE, is a kind of enzyme, and this maltase is specific for maltose, to break down maltose only. Okay, in the presence of water. Okay, in the presence of water, and in the presence of these specific enzymes, maltose can be broken down into 2 simple molecules, 2 glucose molecules. Okay, 1 double sugar become 2 single sugar. Okay, of course, specific enzyme is required in this hydrolysis, in this digestion process. Okay, this is how maltose is metabolized. And after it's broken down into glucose molecules, and it can be absorbed in the small intestine, and then it enters the cell and enter the mitochondrion, and they can be metabolized by respiration. Okay, another example is that the sucrose is broken down by sucrase. Okay, and this is a kind of digestion, a kind of hydrolysis, and glucose and sucrose is hydrolyzed into glucose and fructose. Glucose and fructose, both of them are simple molecules, simple sugar monosaccharides. Okay, and also lactose is hydrolyzed by lactase and become glucose and galactose. Okay, 1 disaccharides become 2 monosaccharides in all these 3 examples of hydrolysis using specific enzyme to break down specific substrate. Okay, and also to remind you that what you learned in Form 3 is not hydrolysis. What you learned in Form 3 is the opposite, the condensation reaction. The condensation reaction and condensation reaction and hydrolysis are opposite opposite direction. Okay, hydrolysis is catabolism and condensation is anabolism. Okay, building up reaction and breaking down reaction. They occur in opposite direction. And look at these reaction. Two monosaccharides, they joined together by condensation reaction. Of course, a specific enzyme is required, of course, and that enzyme is actually the same enzyme as before, and they can catalyze both forward and backward reaction. Okay. With the removal of water molecules, so one H atom is removed, one OH group is removed, so H plus OH become H2O. So that water molecule is removed, become here. Okay, they removed, and this oxygen, the bond here, okay, here, and then this oxygen will join these molecules, okay, this atom, and form a chemical bond here. Okay, so become here. Okay, this oxygen join two molecules together. This oxygen is this oxygen. Okay, and this H2O removed. Okay, this is the condensation reaction. And the opposite is hydrolysis. Okay, you already learned it. And for chemical formula, you know that glucose molecules is C6H12O6. Okay, and for the maltose, the double sugar, the chemical formula is C12H22 and O11. Okay, X equal to 12 and Y equal to 11. And the number of atom is correct when you look at this is two molecules of glucose, 2 C6H12O6 here, but with the molecules of water is removed, it becomes C12H22, not 24, H22 and O11, not 12. Okay, and if you carefully calculate the number of atoms is correct. Okay, after the condensation reaction, so one molecules of water is here, so it is C12H22O11. Okay, this is disaccharides. I have to remind you one more thing is the Benedict's test. The Benedict's test, if you still remember, how to test monosaccharides and disaccharides. The positive result is break wet precipitate. You do a lot of experiment before. You remember that? Okay, the reducing sugar. I have to remind you that all monosaccharides are reducing sugar, and nearly all disaccharides are reducing sugar. Nearly all, not all, many. Okay, because sucrose is an exception. Okay, that's all for disaccharides. Oh no. I want to show you this picture, and this is the structural formula of maltose, and one hexagon here, another. Oh no, this is not maltose. Oh, I'm sorry, this is not maltose. I have to remove this picture and add another picture. Okay, I have to find another picture. This picture. Okay, this is maltose. This is maltose. This is one glucose and one glucose, they join together, and maltose. So sometimes for you to recognize the disaccharide easily, or to represent disaccharide easily, we use this symbol to represent maltose. So I have to add back this diagram here later on. Okay, thank you very much.